All right, welcome. Today, we're going to dive into one of the most fundamental questions in all of artificial intelligence. How does a machine even represent what it knows? We're going to build an AI's logical mind right from the ground up, looking at how it takes in information and, the really cool part, how it uses that information to reason and come up with brand new conclusions. I mean, it's one thing for us humans to understand the world, right? With all its messiness and nuance. But how in the world do you translate all of that into a formal, structured language that a computer can actually get a handle on? How do we really teach a machine to think? So, the very first step is to give our AI a source of truth. Before it can reason about, anything, it needs to know some basic facts about the world it's living in. And this foundation, this starting point, is called its knowledge base. Just think of the knowledge base as the AI's core set of beliefs. It's really just a collection of simple statements, sentences in a logical language, that we tell the AI are absolutely 100% true. Every single conclusion it ever comes up with will be built right on top of this foundation. Okay, so to fill up that knowledge base, we obviously need a language. And we're going to start with the most fundamental one out there, propositional logic. It's a really simple but surprisingly powerful way to represent basic statements about the world. The simplicity here is actually the whole point. These symbols, like P or Q, are kind of like the basic atoms of logical thought. Each one just represents a single, indivisible fact that can only be true or false, nothing in between. So, for example, P could mean it is Tuesday, and Q could mean it is raining. Super simple, super clear, no room for confusion. But of course, the world is way more complex than just a laundry list of separate facts. We need a way to connect these little atoms, some kind of logical glue to build more meaningful sentences. And that's exactly where logical connectives come into play. And here they are, the 5 core tools in our toolkit. We've got not, which, as you'd guess, just flips the truth of a statement. We have and, which is only true if both things are true. Then there's or, which is true if at least one of the things is true. Then we get to the more interesting ones. Implication, that's our classic if-then logic. And biconditional, which basically means two things are true in the exact same situations. It's an if and only if deal. All right, so our AI now has a knowledge base. It's filled with facts, all connected by logic. But just, holding on to facts isn't really intelligence, is it? The real magic happens when the AI starts using those facts to figure out stuff it was never explicitly told. And that whole process is called inference. So inference is what lets an AI expand its own knowledge. Let's say it knows that if it's raining, then the ground is wet. And it also knows that it is raining. It can then infer that the ground is wet all on its own, without anyone having to tell it. That is a leap from just having knowledge to actually reasoning. But how does it actually do that? Well, one of the most straightforward methods is something called model checking. You can really just think of it as a brute force approach, where the AI literally considers every single possibility to see what has to be true. Let's actually see how this works. Imagine our AI's knowledge base says two things, P is true and Q is false. The AI then starts checking out every possible world or scenario. In world 1, P and Q are both true. Well, that can't be right. It contradicts our rule that Q is false. So world 1 is out. In world 3, P is false. Again, that contradicts our knowledge base. Same for world 4. The only world left standing, the only one that's consistent with what our AI knows, is world 2. By just eliminating all the impossible options, the AI has confirmed what must be true. Now, this whole method of checking every possible world, it works. But as our AI starts to learn more and more, it runs into a much bigger problem. The language we're using, propositional logic, it starts to get incredibly clumsy when we try to describe more complex, general ideas. It's time for an upgrade. Just look at this. To say something as simple as every person belongs to a house, we have to write a separate sentence for every single person we know about. It's so tedious, it's inefficient, and it just doesn't scale at all. Exactly. You're probably thinking, there has to be a more elegant way to do this, right? A way to capture these general rules about the world without listing every single example. And luckily for our AI, there absolutely is. And here is the solution, first-order logic. Instead of dozens of sentences, we get one single powerful statement. It says, for all things X, if X is a person, then there exists something Y, such that Y is a house and X belongs to Y. This one sentence captures the exact same idea as all those other statements, but in a much more compact, elegant and powerful way. Now, this power comes from three new tools. First, we have constants, which are just specific objects, like Minerva. Next, we have predicates, which describe properties or relationships, like is a person or belongs to. And finally, the game changers, quantifiers. These are the for all and there exist symbols that let us make those big, sweeping statements about the world. So let's just step back for a second and look at what we've actually built here. We've taken our AI on this journey from knowing absolutely nothing to being able to represent and reason about pretty complex ideas using formal logic. We started with those basic building blocks, propositional logic. Then we gave our AI a way to actually think, to infer new truths using model checking. And finally, we gave it a massive upgrade with first-order logic, which allows it to understand and express general rules about the world. And all of this brings us to a really fascinating final question. We've built a system that is perfectly, flawlessly logical. It can follow rules and derive conclusions with absolute certainty, no mistakes. But does that mechanical perfection actually equal true intelligence? Or is there something more to thinking than just following the rules? Definitely something to ponder.